factor the common factor out of each expression. So here we're going to have a binomial, and we can confirm very quickly that this is not a difference of two squares. It's not a difference. These aren't perfect squares. So we need a different technique in order to solve these. So what we're going to do is we're going to take each individual term and we're going to get the prime factorization of that term. So let's start with negative 63 v to the fourth. And let's get the prime factorization of that. You guys may want to use a factor tree on this. So if we take 63, let's just get two things, whatever we want, that multiply together to give 63. You may recognize this as 9 times 7. 9 we can break down into 3 times 3. 3, you'll notice, can't be broken down any further. That's prime. 7 is also prime. So the prime factorization is 3 times 3 times 7. Notice also that it's negative. The way I'm going to handle that is I'm going to start off with a factor of negative 1. That's going to make this thing negative. So I take negative 1 times 3 times 3 times 7 times v to the fourth, which is v times v times v times v. And now I've run into this a bit. I'm going to erase this now that you've gotten the idea. We'll leave it kind of ghosty there so you can remember what we did. So I took negative 63v to the fourth, and I said that was negative 1 times 3 times 3 times 7 times 4 v's. V to the fourth means v times itself 4 times. Now we're going to do the same thing with 70v squared. We need the prime factorization of 70. 70, you just need two things that multiply together to give that. 7 times 10 would be the obvious ones. 7 is prime. 10 is 2 times 5. 2 is prime and 5 is prime. So there we go. 70 is going to be 2 times 5 times 7 times v times v. Now, when we say common factors, what we mean are the things that are being multiplied within here for both of these. So for instance, I have a 7 that's in both. I have a v that's in both. I have another v that's in both. So what I'm going to do is I'm going to take those things that are common to both of them, and I'm going to use them as sort of, you can think of it almost like community cards. We're going to take these, and I'm going to write a 7 and a v out here that both of these have access to. Well, 7 times v is 7v squared. And I'm going to put that on the outside of a set of parentheses so that it's distributed throughout whatever I put in here. And what I'm going to put in here is what's left over from each one of my terms. So I start with my first term, the negative 63v to the fourth. And what's left from that is negative 1 times 3 times 3 times v times v. So this would be negative 9v squared left over from that one. So notice when I distribute this, I have my negative 1, 3, and 3 is in the negative 9. My 7 comes from right there. V squared from right there, and a v squared from right there. So all of these terms are still there, they're just spread out. Now I do the same thing for here. What's left over is 2 times 5, which is 10. So I'm going to say this is plus 10. And now that right there is my factored expression. So let's do the same thing here for number 18. We have negative 12r. I need the prime factorization of that. I'm going to write a negative 1 to take care of the negative sign, times 2 times 2 times 3. And you can confirm for yourself. 2 times 2 is 4, 4 times 3 is 12. And I can't forget about my r either. Negative 15r squared or r to the 6th, excuse me, I include that negative 1. 15 is 3 times 5, and r to the 6th is 6 r's. Just like that. Now I need to look for what they have in common. They have a negative 1, a 3, and 1 r in common. So multiply all that together, and I would get negative 3r. And I'm going to distribute that throughout what's left from all the rest of this. So from our negative 12r, I have 2 times 2 left over, so that's just 4. And from this one, what I have left over is 5 times 5r's, so that would be plus 5r to the 5th. And that would be my factored expression. The only thing I can think of that's not shown here that might be an issue is what happens if everything gets used up. That is, there are no leftovers, as it were, from one of these expressions. When that's the case, you can just put a 1 in as a placeholder where that 1 was. So again, if everything's used up, you can just throw a 1 in as a placeholder.